Hello, welcome to this lecture video. So today we will be using another inferential statistical test. So our concern here is correlation. So we will be correlating weight and height. So weight in kilograms and height in meters. So we will answer the problem, is there a significant correlation between the weight and the height of the respondents? So in order for us to check what is the applicable test for that, of course, we have to consider again the assumptions of the test. And of course, what are the possible tests that we can use if our concern is not comparison but correlation. So our problem is the correlation. So as mentioned, is there a significant correlation between the weight and height of the respondent? So we are, of course, expecting that the higher the height of the respondent, it means also the heavier the respondent is. But of course, we have to explore before we can see if our hypothesis is true or not. So this is our problem. Is there a significant correlation between height and the weight of the respondents? So looking at our data as presented, since our height is in meter and weight is into kilogram, so we know that our data is numerical. And if it's at this interval or numerical in general, we can use Pearson-r correlation, because for Pearson-r, we can explore the relationship or correlation of two continuous variable and determine whether there is a direct correlation. So that is if the result is positive, or indirect, or rather inverse correlation if, of course, as x increases, y decreases, or vice versa. We also know that we have positive and negative values. And if the result is positive, it means the correlation is positive. And if the result is negative, it means that the correlation is the inverse. So just to present that. So if it is positive and it is negative. We can also describe our result in terms of the strength of the correlation. So how will we know that our correlation is strong or not? So we can actually make use of the number line that if it is, of course, 0, it means that there is no correlation at all. While -1 is perfect correlation, +1 is also perfect correlation, but since it's positive, so it's direct. Negative if it is inverse. So let's divide this so that we can still describe this in terms of strong or weak. So it's a weak if it is within this 0 to 0.5, and it is strong if it is from 0.5 to 1. So similarly, this is also weak and this is also strong. For other materials, you can also describe this steel by dividing it again into 2. Let's say from 0 to 0.25, we can say that this is very weak. From 0.25 to 0.5 is weak, and then strong from 0.5 to 0.75, and very strong from 0.75 to 1. So the same case for, of course, our negative values. So if you will be asking me which strength is higher? Is it the -1 or +1? Of course, the answer to that question is they have the same strength. The strength is 1. It is perfect. The type of correlation is just different. Now, let's go back to our data. Pearson-r is a parametric test. So we need also to satisfy not only its nature of being continuous variables or numerical data, but also to figure out if if the data are normally distributed. So let's clear all drawings and let's go to our file. So here is our data. Let's check the number of respondents. So we have 35 respondents. So we will be using height and weight. So since we have 35 respondents, by central limit theorem, so I'll reiterate that, by central limit theorem, at least 30 is sufficiently large enough. And it also means that the data approaches normal. So we can already conclude that since we have 35 respondents and there's no grouping, so which means we will be comparing 35 data for height and 35 data for weight, then we can proceed to a conclusion that our data is normal. Therefore, we will be using Pearson-r correlation. Okay, let's do the test. So analyze. We will be using correlate and bivariate, which means 2 variables. So we will be placing height and weight in our variable box. So take note that we have here options whether we will be using Spearman-r or Kendall-Stowe or Pearson-r. But Kendall-Stowe B and Spearman-r are non-parametric tests. So since we satisfy the condition of parametric, then we will be using Pearson-r. So by default, we have flagged significant correlations here. So which means if the result is significant, we can expect for an asterisk sign. So click OK. So now what do we have here? So this is now the result showing to us. So we have to look at the value of R. So R is 0.528. So we have here 2 asterisks and it's noted here that it means that it is significant at 1%. So it means that as X increases, height also or rather Y also increases. So in this case, as the higher the weight means the taller the respondent is. So the higher the weight, the taller the respondent is. Or the lower the weight, of course, the lesser value of height. Okay, so here it's 0.528. And if we can still recall what we have presented a while back. So we have a values. So we have a positive, so which means it is a directly correlated. And it's from 0.5, from 0 to 0.5 to 1, from 0.5 to 1. So we know that this is considered strong. And from here, it's considered weak. So it means that we have a strong correlation. We have a strong direct correlation indicating that the higher the weight of, or rather the heavier our respondent is, the higher they tend to have the taller height. Or vice versa. We can also have here weight versus, weight and height, the taller and the heavier the weight of the respondents. So this ends our video. Thank you for watching.